Hello students, in this session we are going to perform pair T and pair W test on the same data file, and the question is about the cholesterol level before and cholesterol level after the program, and 10 readings have been taken regarding cholesterol before and cholesterol after the program from the same 10 patients. So that's the case of dependent samples, because when we take two different readings from the same subject, one before another after, that's considered as the paired results or dependent samples. And dependent samples, in case of dependent samples, we are going to apply to pair T and pair W one by one. So whether to apply pair T or pair W, we need to first go for computing the differences of before program cholesterol level and after program cholesterol level. So we go for transform, compute variables. Target variables is paired differences that I am naming as paired underscore diff. And we select cholesterol before, then minus cholesterol after, and the software will compute this difference variable automatically. Now we go for this to execute, and we can now see in the data file the paired difference variable will be automatically computed. Here you can see. Now for the pair difference, or on the pair difference variable, we have to perform normality test to check if the pair differences are normally distributed or not. For this, we go for explore. We take pair difference variable as the dependent variable. We mark a check across none, and normal probably plots with test. Paste, and then run. If you look at the results, both KS or Kolmogorov-Smirnov-Shapiro-Wilk test indicates or gives us the p-values exceeding 0.05. So normality test is supported, and since normality test supported, we can do the write up in the same way as we have done before for the normality test. So pair differences H naught would be pair differences are normally distributed, and alternative is pair differences are not normally distributed, and following all the steps as usual, we will write down the decision conclusion as since p-value associated with both ks and sw test are not less than 0.05, therefore h naught is not rejected, and it cannot be concluded that the pair differences do not follow normal distribution. And consequently, as a result of this test, we can now proceed for the paired T test. So, how do we perform paired T test? Analyze, compare means. Paired sample T test is the option that we are going to use. So, we take cholesterol level before program as variable 1, cholesterol level after program as variable 2, and we paste this. And now we go to the syntax as usual. We run this syntax for NPAR or non-parametric test, and this is how we get the result. So p-value associated with t statistic is less than 0.05. So we can do the write-up for pair differences or pair t. H naught is mu before is equal to mu after. H1, that's mu before, differs from mu after. Level of significance, let's suppose that's 0.05, and since it is a two-tailed test, therefore alpha by 2 would be 0.025. Test statistic is T with this formula, mean of the pair differences, that is represented as d bar. Mu d bar goes 0 as there is no difference. We mentioned in H naught as d divided by root n, and then decision rule or criterion we write down the same way. H naught would be rejected if significance or p-value associated with t statistic is less than 0.025. Now if you look at the result, the p-value is 0.038. Therefore, H naught is not rejected. So since p-value associated with t statistic is not less than 0.05, therefore H naught is not rejected, and it cannot be concluded that the mean cholesterol before program differs significantly from the mean cholesterol after the program, and consequently we can draw such a conclusion that the treatment is effective in reducing cholesterol level.